Um, a blessed day, everyone. I welcome you to our next discussion about Earth science. Okay, so last meeting, we had discussed about our universe, its origination, and the theories that talked about it. Okay, so now let us try to figure out how does astronomy has built up and made by um, various civilizations and scientists. Okay, so about 10,000 years to the time of the first civilizations and the earliest astronomers who already figured out how to use the sky. Okay, so they were priests and elites who studied the movement of celestial bodies to determine rituals, celebrations, and planting cycles. Okay, so with their ability to observe and even forecast celestial events, these people held great power among their societies. This is because the sky remained a mystery to most of the people, and in many cases, cultures put their gods in the sky. So comets were considered to be mystical and were seen as bad omens and were blamed for a variety of disasters from wars to plagues. Okay, so the Bayeux tapestry, also known as the tapestry of Queen Mathilde or the Tale du Conquest, is an embroidered fabric made in Normandy or in England. It depicts the key events relating to the Norman conquest of England, culminating in the Battle of Hastings. So this event preceded the defeat of King Harold by William the Conqueror. Okay, so these are the following contributions of the ancient astronomers. First, they recorded the locations of the sun, moon, and the five visible planets. They also tracked the motions of heavenly bodies and projected their future positions. And the Chinese kept accurate records of guest stars. Okay, so it is a timeline of the important events and discoveries as the astronomers and inventions in astronomical history. Okay, so on 8000 BC, Warren Field, so this is the Warren Field. So Warren Field is broadly aligned in the direction of midwinter sunrise. Is in the direction perpendicular to the line of beats, and this was framed among prominent hills to the southeast. But it also appears mimic of the to mimic the phases of the moon in order to track lunar months over the course of a year. And a team of British archaeologists had discovered what they believed to be the oldest calendrical monument known anywhere in the world, created by hunter-gatherer societies in Scotland. And this picture is the Gothic circle or Gothic henge. The Gothic circle or Gothic henge is an early Neolithic henge structure with entrances orientated to the rising and setting solstice. So it was apparently created by Europe's first civilization, long before the cultures of Mesopotamia and the pyramids of Egypt. Okay, so the structure had been radiocarbon dated to 4900 BC, and it is one of the best studied of the more than 250 ring ditches identified by aerial surveys throughout Germany, Austria, the Czech Republic, Slovenia, and Croatia. And Gothic, Gothic Circle or Gothic Henge is also considered um, as one of the oldest solar observatories in the world. Okay, and 4500 BC, um, Karnak megaliths. So the Karnak stones have been one of the most puzzling archaeological artifacts in the world for hundreds of years. So these megalithic stones exist around the village of Karnak in Brittany, France. Okay, the stones demonstrate alignments, dolmens, and other ancient geometry which is consistent with other prehistoric sites. So this is the largest such collections of stones in the world. Okay, so in 3500 BC, um, Country Ifan. The most popular megalithic site in Wales. Um, Country Ifan is a splendid burial chamber with a huge capstone delicately poised on three uprights. Okay, Country Ifan means Ivan's village. In 3200 BC, New Grange Tomb. The New Grange is a Stone Age monument in the Boyne Valley, County Meath, Ireland. So it was built about 3200 BC during the Neolithic period, which makes it older than Stonehenge and the Egyptian pyramids. The New Grange is a large circular mound with a stone passageway and chambers inside. So the mount is arranged by large stones known as curbstones, some of which are engraved with artwork. 3000 BC Stonehenge. Okay, Stonehenge is a massive um, stone monument located on a chalky plain north of the modern day city of Salisbury, England. Stonehenge is just one part of a larger sacred landscape that contains many other stone and wooden structures as well as burials. And at the same year, we have the Sumerians. The Sumerians and its star chart. Okay, so among the first astronomers mapping the stars into sets of constellations, many of which survive in the zodiac and um, were also recognized by ancient Greeks. Okay, so they were also aware of the five planets that are visible to the naked eye and the constellations of Leo, Taurus, Scorpius, Gemini, Capricorn, and Sagittarius were invented. So with these zodiac constellations, also marking the path of the sun, moon, and planets throughout the year. In 2500 uh, BC, the Egypt's pyramids. The ancient Egyptians built pyramids as tombs for the pharaohs and their queens. So the pharaohs were buried in pyramids of many different shapes and sizes from before the beginning of the Old Kingdom to the end of the Middle Kingdom. Okay, so the three largest and best preserved of these were built at Giza, so at the beginning of the Old Kingdom. And the most well-known of these pyramids was built for the Pharaoh Khufu, and it is known as the Great Pyramid of Giza. In 2000 BC, um, the first solar lunar calendars were put into use in Egypt and Mesopotamia, known as solar calendars. These calendars consist of 12 lunar months, and the calendar is not linked to the seasons and drifts by 11 days every year, coming back to its original dates every 33 Islamic years. And 1450 BC, the Egyptian dial. So the sundial is one of the world's oldest scientific instruments designed to tell the time to the nearest hour. The ancient contraption was first created by the Babylonian and Egyptian civilizations and works by measuring the sun's movement across the sky. Okay, so on 1400 BC, Chinese recorded solar eclipse. Okay, so throughout the centuries, Chinese astronomers devoted substantial efforts toward predicting eclipses. However, like all similar efforts prior to the Renaissance, this could only be by empirical research. Okay, so the earliest record of a solar eclipse comes from ancient Chinese history. And the ancient Chinese astronomy was primarily a governmental activity. It was the astronomers' role to keep track of solar, lunar, and planetary motions and explain what they meant to the ruling emperor. And 2001 to 1500 BC, the Balnuwaran of Clava. So this particular site is made up of three individual cairns that, as a group, form a straight line northeast to southwest. The term Plaba was originally used in order to categorize these three cairns. So two of the three current entrance passages align exactly with the sun's setting position on the winter solstice. Okay, so 1000 to 800 BC with the Fossa stones and Yajnavalkya. This is the foot of Fossa stones. Okay, so you can see in this picture the standing stones are arranged in straight lines and in circles. Okay, so these stones mark a burial ground for the ancient Vestini tribe, and it is located in Italy. Okay, the stone slabs that are set in straight lines are aligned east to west, thus seeing the cycle of the sun. And this is Yajnavalkya, an Indian astronomer that proposes a heliocentric concept of the universe in which the Earth is spherical and the Sun is at the center of the spheres. And the 500 BC Babylonian Astronomy. The astronomy plays a central role in Babylonian religion. The priesthood attempts to read the will of the gods from the heavens and advises the king accordingly, and this provides a strong motivation to study the sky. So, this is the ruin of the ziggurat of Bersippa and the sexagesimal number system. On 450 BC, Anaxagoras. So, Anaxagoras was one of the most famous of early Greek philosophers. He is credited with turning Athens into a center of ancient study and intellectual activity. He also suggests that the stars are actually sun, similar to our own. 384 BC, Greek astro- Aristotle. So Aristotle concluded that the Earth is spherical because it always casts a curved shadow when it eclipses the moon. He believed that the Earth is the center of the universe, and his Earth-centered view dominated for almost 2,000 years. The golden age of astronomy, so the Greece 600 BC to AD 150. Okay, so the Greeks used purely philosophical arguments to explain natural phenomena, but employed observational data as well. So they developed the basic of geometry and trigonometry, measures the sizes of and distance to the largest appearing bodies in the heavens, such as the sun and the moon. The first people to use physical models in astronomy. So the beliefs of the ancient Greeks are all the heavenly bodies except seven appeared to remain in the same relative position to one another. The seven wanderers, fixed stars, so the Sun, Moon, Mercury, Venus, Mars, Jupiter, and Saturn, each was thought to have a circular orbit around Earth. The Greeks held the incorrect geocentric view of the universe. So geo means Earth and centric is centered. So the geocentric view, Earth was a sphere that remained motionless at the center of the universe. So Moon, Sun, and five known planets maintained circular orbits around the Earth. The seven wanderers, or planetae in Greek. So beyond the planets was a transparent hollow celestial sphere on which the stars were attached and traveled daily around Earth. Some early Greeks realized that the motion of the stars could be explained just as easily by a rotating Earth, but they rejected that idea. Why? Because Earth exhibits no sense of motions, and Earth seems too large to be movable. So, proof of Earth's rotation was not demonstrated until 1851. Okay, so on 240 BC, we have Eratosthenes. Okay, so he measured the Earth's circumference, observed the angles of the noonday sun in two Egyptian cities, the Shini, presently Aswan, and Alexandria. On 130 BC, Hipparchus of Greece managed to develop the first accurate star map and catalog that has over 850 of the universe's brightest stars. Hipparchus is the father of trigonometry, also developed the system of epicycles where everything in the universe revolves in perfect circles, fitting Aristotle's Earth-centered universe theories. The next, 45 BC, the Julian calendar. So the Julian calendar is a reform of the Roman calendar introduced by Julius Caesar in 46 BC, and it took effect the following year, 45 BC, and continued to be used as the civil calendar in some countries into the 20th century. So the calendar has a regular year of 365 days divided into 12 months. A leap day is added to February every 4 years. And yeah, the Julian year is therefore an average of 365.25 days long. And 28 BC, Chinese record sunspot. Okay, so sunspots were first observed and recorded in China during the Shang Dynasty. 140 AD Ptolemy. So, although many of the Greek discoveries were lost during the Middle Ages, the Earth-centered view that the Greeks proposed became entrenched in Europe. So, presented in its finest form by Claudius Ptolemy, this geocentric look became known as the Ptolemaic system. So, Clausius Ptolemy. So, presented a summary of Greek astronomical knowledge, compiled a 13-volume treatise, uh, the Almagest, the great work, is to develop a model of the universe that accounted for the observable motions of the celestial bodies. So Ptolemy's model, star-studied celestial sphere, made a daily trip around a motionless Earth. And the sun, moon, and planets made trips of various lengths along individual orbits. The retrograde motion. Each planet, if watched night after night, moves slightly eastward among the stars. So periodically, each planet appears to stop, reverse direction for a period of time, and then resume an eastward motion. So the retrograde motion of Mars. So because Earth has a faster orbital speed than Mars, it overtakes its neighbor. So while doing so, Mars appears to be moving backward in retrograde motion. The Ptolemy's explanation of retrograde motion. Okay, planets move on small circles or epicycles while they orbit Earth on larger scales, the difference. So through trial and error, Ptolemy discovered the right combination of circles to produce the retrograde motion observed for each planet. The procession with Ptolemy's model to predict planetary motion went virtually unchallenged until the 17th century. So when Ptolemy's predicted positions for the planets became out of step with the observed positions, his model was simply recalibrated. And 200 AD, the Teotihuacan Pyramid. The most famous single pyramid in Latin America is the Pyramid of the Sun. According to Aztec tradition, the sun and the moon, as well as the rest of the universe, trace their origin to Teotihuacan. Um, in 250 AD, we have the Mayan pyramids. The largest pyramid built by Mayans is situated in Oxmal, Yucatan, Mexico. So this place was used as teaching and discussion session for intellectuals like astronomers, mathematicians, scholars, and priests. So this great pyramid is known as the Pyramid of the Magician, owing to its amazing constructions that is aligned with planets that were discovered at that time. So in 350 AD, the Nazca culture. The Nazca culture was established in the Peruvian region of Ica. The German archaeologist Friedrich Max Olli was the one who discovered the Nazca culture in the year 1900s. 476 AD, Aryabhata. Aryabhata is an Indian astronomer. Okay, so um, he proposed the heliocentric theory. So man reflects lights of the sun and eclipse forecasting. And in 500 AD, Anasazi. So um, the term is Navajo in origin and means ancient enemy. So the Pueblo peoples of New Mexico understandably do not wish to refer to their ancestors in such a disrespectful manner. So the appropriate term to use in ancestral Pueblo is ancestral Pueblo or ancestral Puebloan. In 637 AD is the Chum Chumsung Bay Observatory in Kyungju, Korea. So this simple structure with a central opening in the roof resembles a number of ancient observatories found around the world. Okay. So 920 AD, the Oxmal Pyramid. So Oxmal was a Mayan city of significant importance during the 10th century, which the Pyramid of the Magician uh, is one of the best ruins. It directly faces the rising sun on summer solstice. 940 AD, the oldest Chinese star map. So the Dunhuang chart is the oldest preserved star chart in the world. So the star map has recently been dated back to the 700s, and earlier uh, it was thought to date to the 900s. Okay, so the map contains 1,350 stars in 13 sections. So one of the most interesting features of the charts is that they use two different methods to display the stars. One was a cylindrical projection for the stars around the horizon. 970, Al-Sufi. So Al-Sufi is one of the famous nine Muslim astronomers who made the earliest recorded observation of the Andromeda galaxy. 1000 AD Caracal Pyramid. So Caracal's ancient Mayan name was Oxwitza, or Three Water Hill. So its early classic name was Oxwitz Ajau, or Three Hills Lure. Okay. Caracal is the largest Maya site in Belize, covering about 75 squaring mile. Yeah, 75 square miles. And 1054 AD, Chinese observed supernova in Taurus. The Chinese recorded the sudden appearance of gas star. So the scattered remains of that supernova is the Crab Nebula in the constellation Taurus. So the Crab Nebula, Messier was first noted by Chinese as nova gas stars. Okay. In 100 in 100 and 1120 AD, Cairo Observatory. So in Cairo, Egypt, a large observatory begins being constructed. So it's believed to be possibly the first observatory in medieval Islam, but it is never completed. So the observatory's patron is convicted for communicating with Saturn and executed. Okay, so in 1125, the observatory was destroyed. On 1200 AD, the Incan civilization. The Inca tribe, led by Manco Capac, founded the city of Cuzco in the Cuzco Valley region. So the Inca considered themselves to have been chosen by their gods to rule mankind, and believed that Cusco was at the center and end of the universe. 1259 AD, the Maragha Observatory. So it was built by a Persian astronomer, Nasr al-Din al-Tusi. So in 1300 AD, the Aztec civilization. The Aztec are so called from Aztlan or White Land, an allusion to their origins probably in northern Mexico. So the Aztecs were famous for their agriculture, cultivating all available land, introducing irrigation, draining swamps, and creating artificial islands in the lakes. They developed a form of hieroglyphic writing, a complex calendar system, and built famous pyramids and temples. In 1420 AD, the Olag Beg's Observatory. So it is located near the city of Samarkand in present day Uzbekistan. So Olag Beg Observatory was built in the 1420s by the Timurid ruler Oleg Beg, grandson of Emperor Timur the Lame or Tamerlane, and known more for his scholarly pursuit than his governance skills. So Beg proved uh, unpopular as a ruler. 1483, the Alphonsine tables. The Alphonsine tables is the last great attempt to make the Ptolemaic system of practical use because of the errors accumulated as centuries passed. A updated version of the Almagest of Ptolemy, the book of apparent motions of stars and planetary uh, path. Okay, so took 10 years to simplify the calculations that are led by King Alfonso X of Castal's astronomers. Okay, so the first set of astronomical tables prepared in Christian Europe, so they enabled calculate the eclipses and the positions of the planets for any given time based on the Ptolemaic theory, so which assumed that the Earth was at the center of the universe. And 1543, Copernicus. Nicholas Copernicus, convinced by Aristarchus' writings that Earth is a planet, constructed a heliocentric model for the solar system, used circular orbits, was unable to accurately predict the future locations of the planets, and added smaller circles, vesicles like those used by Ptolemy. 1572, Tycho Brahe became interested in astronomy while viewing a solar eclipse that have been predicted by astronomers, and persuaded King Frederick II of Denmark to establish an observatory near Copenhagen, designed and built pointers which he used for 20 years to systematically measure the locations of the heavenly bodies in an effort to disprove the Copernican theory. 1582, the Gregorian calendar. So the Gregorian calendar is the calendar used in most of the world. So it was introduced in October of 1582 by Pope Gregory XIII. However, nearly every 4 years is a leap year when one extra or intercalary day is added on February 29. Okay, so making the leap year in Gregorian calendar 366 days long. 1604, Johann Bayer. So introduces a Bayer designation of stars, assigning Greek letters to stars still in use today. So a Bayer designation is a stellar designation in which a specific star is identified by a Greek or Latin. So Latin letter followed by the genitive form of its parent constellation's Latin name. 1608, Hans Leperche or Hans Leperche, also known as Johann Leperche. He is commonly associated with the invention of the telescope because he was the first one who tried to obtain a patent for it. Okay. Okay. 1609, Galileo Galilei is the greatest scientist of all times. So became the first person to observe the moon and planets through telescope. So he also discovered four of Jupiter's moon. In 1609, the same year, Kepler first and second. So Johannes Kepler's law of planetary motion, so law of elliptical orbits. All planets move in elliptical orbits around the sun, with the sun at one focus of the ellipse. Law of equal areas, an imaginary line, a radial vector, um, um, joining a planet to the sun sweeps out equal areas in equal periods of time. So perihelion is closest point to the sun, and aphelion is the farthest point to the sun. And IU, or astronomical unit, is the convenient unit for expressing distances in the solar system. So in 1656, I have Christian Huygens. So he was a Dutch physicist and astronomer. So found new methods for grinding and polishing lenses, making telescopes more powerful. So Huygens first identified Saturn's ring and one of the Saturn's moon also. And he invented the pendulum clock, increasing the accuracy of timekeeping, and proposed the wave theory of light. In 1668 na Newton the the first reflecting telescope was built by Newton. So using a concave primary mirror and a flat diagonal secondary mirror. And 1675, Ole Romer. So Danish astronomer Ole Romer measures the speed of light. So he was the first to determine the study of the moons of Jupiter that light has a finite speed. And 1687, Newton theory of universal gravitation. So Isaac Newton studied optics, divined the nature of gravity, and invented calculus. So he recognized that force of gravity decreases as the square of the distance between the objects increases. So this Isaac Newton has the three laws of motions. So the first law is an object in motion must continue in motion in a straight line unless it is acted by a force. And the second law is often stated as F equals ma, which means the force F acting on an object is equal to the mass of an object times its acceleration. And the third law is for every action, there is an equal and opposite reaction. So if one body attracts, another second body must also attract the first, thus gravitation is mutual. Okay, and In 1705, Edmund Halley, so he predicted the comet's return about every 75 years. He also studied the Earth's weather and magnetic field and the ocean's tides. 1758, Johann Pallich observes Halley's comet as predicted by Halley in 1705. So two craters and a valley on the moon are named after him. So he was also the first farmer to cultivate. 1781, William Herschel. So he found the planet Uranus and its two moons and formulated a theory of stellar evolution. So he discovered a new planet beyond Saturn. And he is an organist, composer, and enthusiast of stargazing. So who would become one of the greatest astronomers of all time. 1781, same year, Messier. So Messier, he discovers galaxies, nebula. He discovers galaxies, nebula, and star clusters while looking for comets. So he compiles a catalog of these objects or the Messier objects. So identified 103 nebulae as part of his catalog. So in 1801, Piazzi discovered the first asteroid series. In 1846, Johann Gale, he observes and discovers Neptune. His observations were prompted by mathematical calculations by French Joseph Leverrier and English astronomer John Couch Adams. Okay, so in 1905, George Hale, Mount Wilson Observatory was established for study of the sun. Next, 1908, Hertz sprung. So Hertz sprung describes giant and dwarf stars. So the correlation of color with true brightness became the basis of a widely used method of deducing the so-called spectroscopic parallax of stars, so estimates of their distances from the Earth. 1911, the Hertz-Sprung and Russell diagram. So it's a graphical tool that astronomers use to classify stars according to their luminosity, spectral type, color, temperature, and evolutionary stage. So HR diagrams are valuable because they reveal important information about the stars plotted on them. 1916, Albert Einstein. So he came up with many original theories and invented modern physics. So he is most famous for his theory of relativity, which makes bold statements about the nature of life. So shows the relationship between mass and energy, and Einstein's accurate predictions and the link between gravity with space and time. Um, on 1923, Edwin Hubble. So his observations of galaxies helped him develop the idea of an expanding universe, which formed the basis of modern cosmology, the study of the origin of the universe. He also discovered a relationship between a galaxy's speed and its distance. So the Hubble Space Telescope are currently on an observation project in space. In 1930, Clyde Tombaugh. So Clyde is an American astronomer who discovered Pluto in 1930 after a systematic search for a ninth planet investigated by the predictions of other astronomers. So he also discovered a number of asteroids and minor planets, and he was one of the supporters of further research to better understand UFOs or um, an unidentified flying object. Okay, why Pluto is no longer a planet? Okay, so the International Astronomical Union or IU downgraded the status of Pluto to that of a dwarf planet because it did not meet the three criteria of IU that uses to define a full-size planet. So essentially, Pluto meets all the criteria except one. It has not cleared its neighboring region for other a region of other objects. So, 1937, Groth Reber. So, he was an American astronomer and radio engineer who built the first radio telescope and was largely responsible for the early development of radio astronomy, which opened an entirely new research in front in the study of the universe. In 1957, Sputnik is the first object to orbit the Earth launched by the Russians. In 1961, Yuri Gagarin became the first person in space when he flew aboard the Vostok spacecraft in 1961. He orbited the Earth once on this historic flight. The flight lasted 1 hour and 48 minutes. 1962, John Glenn becomes first American man to orbit the Earth. He has spent almost 219 hours in space on two space flights. He flew aboard the Mercury 7 spacecraft named Friendship 7. Apollo 1969, the Apollo mission. So Apollo 11 was the name of the first mission to succeed in landing a person on the surface. The US rocket Saturn V was launched and 3 days later successfully deployed the Lunar Landing Module Eagle, which landed in the Moon's Sea of Tranquility. And in 1970, Venera space probe. So the Russian Venera 7 becomes first to land softly on the surface of Venus. Okay, so let us now proceed to the Philippine astronomy. So 1865, Observatorio de Meteorológico de Manila. So work in astronomy in the Philippines started in 1897. So it was one of the functions of the Observatorio de Meteorológico de Manila or OM, which performed not only meteorological and astronomical services, but also seismological and terrestrial magnetism services. So its astronomical activities were mostly limited to timekeeping and observation of solar and stellar phenomena. So the OM began as a private institution in 1865 and became a government agency as the Weather Bureau in 1901. So with its observatory in Manila as its central office. Okay, so during the Second World War, I mean Second World War, the astronomical observatory was destroyed. So in 1954, uh, Pag-asa Pag-asa Astronomical Observatory. So, new observatory was constructed within the campus of the University of the Philippines in Quezon City in 1954. Okay, so it remained there up to the present time, now under the Philippine Atmospheric Geophysical and Astronomical Services Administration, or PAG-ASA, as the only government observatory. Okay, so from 1954, the observatory has not seen any major change until 1998. In 2009, um, RTU students, RTU astronomy students were able to view and participate in imaging the partial solar eclipse. Okay, so in 2015, Pag-asa acquired a new time machine known as the Precise Time Scale System of Pag-asa, okay, to create a national timing reference and to comply with the requirements of the existing laws on time and frequency services in the country. Okay, Pag-asa has purchased um, devi- a new timing devices. Okay, so 2016, uh, Diwata 1 is the Philippines' first microsatellite designed, developed, and assembled by Filipino researchers and engineers under the guidance of Japanese experts from Hokkaido University and Tohoku University. So the satellite is designed to provide real-time images for disaster risk management and other applications. Okay, so the potential uses of the Wata 1 include um, include the improved weather detection and forecast, disaster risk management, detecting agricultural growth patterns, and the monitoring of forest cover, mining, protection of cultural and historical sites, and the territorial borders of the Philippines. Okay, in August 10, 2018, Maya 1 was developed by two Filipino students at the Kyushu Institute of Technology, or QTech, in Japan, and is still in space since its launch in 2018. Okay, so it contains an automatic packet radio service digipeater which can communicate with ham radios. Okay, so it also carries two cameras that have a wide angle and narrow angle lens to capture images and videos for research purposes. And after 2 years, um, After 2 years of successfully completing its mission, Maya 1, the country's first nanosatellites, flew back to the Earth's atmosphere on November 23. Okay, so according to Adrian Salces, one of the Filipino graduate students who developed Maya 1, the satellite was expected to stay in orbit for less than a year, but it had stayed in orbit for about 2 years and 4 months. Okay, so on October 29, same year, 2018, Diwata 2 is the Philippines' second microsatellite designed and developed by Filipino scientists and engineers under the Philippine Microsat program. Okay. It also carries an amateur radio unit. So this payload is intended to promote awareness and interest in amateur radios and satellite technology in the country. Okay. It also tends to provide an alternative means of communications at times of disasters and emergencies. Okay, so recently, last April 11, Duwata Aru was designated as Philippines Oscar 101 by the Radio Amateur Satellite Corporation, or AMSAT. And lastly, 2019, the Philippines Space Act. So the President Rodrigo Duterte has signed into Law Republic Act 11363, or the Philippine Space Act, okay, which enables the Philippines to establish its own national space agency. The Philippine Space Agency, or PhilSA, is created under the Act, so to be the country's officials representation in the international space community for establishing cooperation agreements and linkages on space developments. And that's all for this session. So thank you for listening, and God bless everyone. Keep safe,